Pluto was once considered the outermost planet in our solar system, but it has since lost its status as a planet and has been reclassified as a dwarf planet. Despite this, it remains one of the most fascinating celestial bodies to study. The New Horizons mission has enabled us to observe Pluto in ways never before possible, providing not only stunning images of this distant small planet, but also a great and unexpected surprise that opens up incredible new opportunities. Before embarking on the exploration of this wonderful and surprising celestial body, remember to support us by subscribing to the channel and activating the bell so you don't miss our new videos. Pluto was the last planet in the solar system to be discovered, and it was also the first to lose its planetary status. On August 24, 2006, Pluto was stripped of its designation as a planet and officially became known as a dwarf planet or planetoid. This reconsideration in the scientific community came after the discovery of many celestial bodies in the Kuiper Belt, similar in size to Pluto. To avoid confusion in the definition of a planet and to prevent the list of planets in our solar system from becoming excessively long, new criteria were introduced. To be defined as a planet, a celestial body must orbit its star, have enough mass and gravity to force it into a spherical shape, and be able to clear away any other similar-sized objects near its orbit. In our solar system, only 8 planets meet these criteria. Pluto meets only the first 2 requirements, which is why it has been classified as a dwarf planet. Despite its reclassification, the discoveries made about Pluto make it an extremely interesting celestial body. It all started in 2003 when the New Horizons probe was placed atop the Atlas V rocket and launched from Cape Canaveral Space Station in the United States. It took the probe 9 years to reach its destination. Scientists had to solve several problems during the years of travel, but the information sent back did not disappoint and exceeded expectations. The project manager of the mission, Professor Alan Stern, stated that New Horizons exceeded all the most optimistic expectations and also gave us an unexpected surprise. Pluto possesses characteristics that make it quite similar to Earth, despite its small size. Its mass is even less than that of the Moon. On its surface, one can marvel at frozen lakes, mountains, and enormous chasms, larger than the Grand Canyon in the United States. Additionally, it has an atmosphere that colors the sky blue, but unfortunately, it lacks oxygen. The atmosphere of this dwarf planet is composed of nitrogen, methane, and carbon monoxide, with a pressure about 100,000 times lower than that of our planet. The average surface temperature ranges between -226 and -240 degrees Celsius. Pluto has 5 moons, the most interesting of which is Charon, located just 19,600 kilometers from its surface. To put this in perspective, the distance between Earth and the Moon is 385,000 kilometers. This means that the tidal force between the dwarf planet and its moon is very powerful. According to the laws of celestial mechanics, in such situations, the rotation of the 2 celestial bodies becomes synchronous, meaning Charon always shows the same face to Pluto. Moreover, Charon is more than half the size of Pluto, and due to this remarkable size ratio, it is often referred to as a double system. Pluto appears very bright, with its surface divided into very light and darker areas. One of these lighter regions, named Sputnik Planitia in honor of Sputnik, the first human-made object to leave Earth, has drawn significant scientific interest. Observations reveal that this region occupies nearly a third of the celestial body's total surface, appearing extremely smooth with no signs of impact craters from asteroid collisions. This suggests that the region is relatively young, estimated at about 100 million years old, and indicates ongoing surface renewal on the dwarf planet, similar to what happens on Earth. However, there's another unexpected aspect that has captivated scientists. Sputnik Planitia was presumed to be a hollow basin filled with frozen nitrogen. but observations made using images sent by the New Horizons probe revealed a significant anomaly. The images show cracks in the frozen ground, which typically form when a surface expands. Given that the temperatures on the dwarf planet are cooling, this suggests that beneath the nitrogen crust, there is a substance that is expanding. What substance expands instead of contracting when frozen? Water. It's likely that beneath Pluto's frozen surface lies an immense basin of water still in liquid form. But how has this water remained unfrozen given the extremely low temperatures present? Scientists believe that the heat source on Pluto could originate from two possible sources. The first source might be the heat released during the decay of radioactive elements inside the dwarf planet. The second source could be the release of gravitational energy. Additionally, scientists have hypothesized that beneath the icy surface of Sputnik Planitia, there might exist an insulating layer of gas hydrates. Gas hydrates are solid compounds formed from water and natural gases of low molecular weight, which occur in environments with low temperature, high pressure, and sufficient gas concentration. These gases have very low thermal conductivity and could therefore have insulated and protected the subsurface basin. To confirm this hypothesis, a computer simulation was conducted, which affirmed that water beneath Pluto's surface could remain liquid only if there is a layer of gas acting as an insulator. Without this natural insulator, the water would have frozen within a few 100 million years, and we would not be witnessing this phenomenon today. According to this theory, methane from the deeper layers of the planet could have been trapped and acted as an insulator. This might also explain the unusual composition of Pluto's atmosphere, which is low in methane but high in nitrogen. Today, with the help of next-generation telescopes, scientists are searching for liquid water in the habitable zones of solar systems thousands of light-years away. The idea that a dwarf planet like Pluto might contain this precious resource beneath its surface is astounding. If such a distant planet from its star can hold such a surprise, these conditions might also be present on other dwarf planets in the Kuiper Belt, celestial bodies sharing a history very similar to that of Pluto. Water, as we know, is a fundamental element of life. Even though the conditions on Pluto are extreme, the presence of an ancient ocean billions of years old could even suggest the existence of elementary forms of life within it. After all, on Earth, in similar environments, we have found life forms, such as in Lake Vostok in Antarctica, a massive lake beneath the Arctic ice that has been isolated for thousands of years from the external environment, yet still harbors life. To definitively answer whether liquid water exists beneath Pluto's surface and to investigate if there are elementary life forms, the only option is to send a new mission to explore the dwarf planet. A probe capable of digging beneath the ice and extracting a sample could reveal that such conditions are much less rare than we think, and that a precious element like water is present both in our solar system and the universe in places we never imagined. What do you think? Will Pluto reveal more surprises? Let us know your thoughts in the comments, and don't forget to subscribe to our channel to not miss our new videos and continue this wonderful journey with us into the mysteries of the universe.